In this video, I'll discuss common techniques used in defensive programming. There are four cornerstones of the defensive programming approach. First, don't trust users, and many developers can probably relate to this. Next, anticipate the impossible, which of course is easier said than done. Assume something will go wrong, which is easy to do but more difficult to pinpoint. And write clean code, so there's the tie-in with clean coding. Applications need to behave predictably, even in the face of the unpredictable. We all know that, but in defensive programming, it's a major focus, and as a developer, you can control this. But users are by nature unpredictable, and you cannot control this. So the bottom line in defensive programming is don't write bad code. Now, that may sound funny because you never hear anyone tell you to absolutely write bad code, so it kind of goes without saying, right? Well, think about it. Everyone knows that you shouldn't write bad code, but does that mean that bad code doesn't get written? Of course not. The defensive programming process involves a thorough design process where the team anticipates and designs for safety in the sense of avoiding dangerous situations for a software product. The team also anticipates and designs for security because, of course, the attack surface is a concern for software that needs to be always available. The software is designed with testing in mind, and good defensive programmers always use good, up-to-date testing tools. In addition to planning ahead of time, defensive programming is very much a part of the code creation process. In defensive programming, you assume your team will create coding errors. It's just a fact of life. Various techniques can be used, and it's up to the developer to determine ahead of time what they'll adopt. For example, creating default cases, such as the kind used in switch statements, which ensures that the statements won't crash an app for a lack of a result. Other examples of techniques include using initialized properties for objects, using immutable objects where possible, creating testable blocks of code, that is, make testability a focus of the code creation process, and avoiding exception handling where possible. The idea here is that you need to have continuing functionality, and rather than spending time and money on exception handling, perhaps instead you'd create functions or other programming structures to handle the way exceptions are dealt with.